All right, y'all. This is 5.5, the last section before exam 2. Ooh, all right. So we've been graphing polynomials and rational functions, and now today we are going to solve polynomial and rational inequalities. And there's two ways you can do this. You can, 1, graph it, or 2, solve it algebraically by making a number line, which is a lot faster. So we'll start off with the polynomial function that we are going to graph. So we remember everything we do to graph a polynomial. And then we're going to do a bunch of work just to answer one simple question. Like all this work to answer one simple question. Where is the graph above the x-axis? That's what we're going to do. We put in a bunch of work just to answer one simple question. And of course, it all depends on the inequality. So it could be, where's the graph above the x-axis, below the x-axis, above or on, below or on the x-axis. It all depends on the inequality. All right, so let's get started. We want to solve x plus 3x minus 1 squared greater than 0. So we want to know, where is this function going to be above the x-axis? And we start by graphing, or going through the steps of graphing this polynomial function. And the first step is to determine the end behavior. Okay. So first off, to determine the end behavior, we have to know the degree of the function. So this degree is 1, that degree is 2. So our degree is 3, which is odd. And then we have to know what the leading coefficient is. The leading coefficient is 1, which is positive. So now, if you have an odd degree with a positive leading coefficient, we open bottom left to top right. Fit my arms in the box, right? So we open bottom left to top right. Okay, odd degree, positive leading coefficient. Next is, what are the intercepts and their multiplicities? So here we'll find the X intercepts. You set f of x equal to 0, and we'll have x plus 3 times x minus 1 squared equal to 0. Fair enough. We get x equals -3 and x equals 1. These are the x intercepts, -3, 0, and 1, 0. The multiplicity on -3 is 1, which means it will cross. The multiplicity on the x-intercept of 1 has a multiplicity of 2, which means we will touch. Then next is the y-intercept, which we let x equal 0. We'll get f of 0, and I'll get 0 plus 3 times 0 minus 1 squared, giving me 3 times -1 squared, giving me just 3. So 0, 3 is our y-intercept. Okay. Hey, that wasn't bad. Next is the turning points. If the degree is 3, then our turning points is going to be 2. And now we graph. All right, let me look at my values. I have 3, 1, and y value is 3. So I can space this out. So down here is going to have 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Negative, 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 negative. And then I think I can even space out my y values. Why not? 1, 2, 3, 4, 5. Okay. Plot my x-intercepts. I have one at -3. I have another one at 1. My y-intercept is at 3. And we are now ready to graph. Okay. -3, 1. That's going to look super weird. Okay. So come down and graph, and we go bottom left to top right. So we'll come up, cross, cross, oops, do it in one go. Touch, and go. Okay, there's our graph. And now we have done all of this just to answer one simple question. Where are we above the x-axis? What intervals of x are we above the x-axis? And read the graph from left to right. We're not above the x-axis until -3. So everything down here is below. And then after -3, we go above, and we go above all the way till we get to 1. So -3 to 1. And then union, we start again at 1 and head towards infinity. There's our answer. Okay. And it has to be a union of 1, because if you were exactly on 1, this means that you would be on the x-axis. And we're only looking for above the x-axis. Okay. And that's how you solve a polynomial inequality. You can graph it and then use all that information to answer that simple question. Now, if you absolutely hate graphing, well, lucky you. The next one is solving the inequality algebraically. No graph involved, which is perfect, because this means we do not care about end behavior. We do not care about turning points. We do not care about a y-intercept. We just care about x values on a number line. That's it. Couldn't get easier than that, I think. Okay, so solve this inequality algebraically. X cubed minus 2x squared minus 3x less than or equal to 0. So the first thing we want to know is, can we rearrange the inequality? Meaning, is there anything to the right of the inequality? So let's say if the problem started off as x cubed minus 2x squared less than or equal to 3x. When we say rearrange, we would say have 0 on one side. So you would move the 3x over and end up getting the inequality above. So that's what the first step's always about. Can you rearrange it? And you probably should rearrange it. You want all the terms on one side and you want 0 on the other side. Okay. So this can't be rearranged because it's already in perfect form. So we're going to move on to step B. So let's say A, done. B, take the function, set it equal to 0, and solve for x. Take an x out, you get x squared minus 2x minus 3 equal to 0. Factor that, you get x times x plus 1, x minus 3 equal to 0, x squared, negative 3 plus 1, negative 2, negative 3. And now it's completely factored, so set each term equal to 0. You're going to get x equals 0, x equals negative 1, and x equals 3. Our degree was 3. That means I should have 3 zeros. Okay, step B is done. We found the zeros. No need to put them into intercept form as an actual coordinate unless MyMathLab asks you to, but there's no need to right now. Okay, step C. Use these zeros, the roots, the intercepts to create intervals on a number line. So that's step C. Here's my number line, negative infinity to infinity. And I'm going to plot my x values. -1, 0, and 3. -1, 0, and 3. And now we're going to make intervals. Negative infinity, -1, -1 to 0, 0 to 3, and 3 to infinity. Okay. And now after that, we are going to pick test numbers. And what those test numbers are going to tell us, whatever the outcome is going to tell us where we are above the x-axis and below the x-axis. So test numbers from negative infinity to -1, I'm going to pick -2. From -1 to 0, I'm going to pick -0.5. From 0 to 3, I'm going to pick 1. And from 3 to infinity, let's pick 4. And you'll have f of -2, f of -0.5, f of 1, f of 4. Okay. Oh, looky who I brought today. My calculator. Let's just go with the graphing. Let me find the function. X cubed minus 2x squared minus 3x. So x cubed. Oh, what are you doing? X cubed minus 2x squared minus 3x. X cubed minus 2x squared minus 3x. Enter. Second graph. Delete anything that's there. And now I'll come down to my numbers. And honestly, since we're not graphing anything, we can care less about the number. We only have to care about the sign of the output. So -2, -0.5, 1, and 4. I get, at -2, you get a negative output. At -0.5, you get a positive output. At 1, you get a negative output. And at 4, you get a positive output. And once again, I'm not writing the number because we're not graphing anything. We only care about the sign because the sign tells us what we are doing. It tells us where we are above or below the x-axis. So let's check it out. So the first sign is negative. This means that from negative infinity to -1, we are below the x-axis. The next sign is positive. This means from -1 to 0, we are above the x-axis. The next one from 0 to 3 is negative, which means we are below. And then the last one's positive from 3 to infinity, which means we are above. And now step C is done. D, all we want to know now is on what intervals are we less than or equal to 0? That was the original inequality stated. So D. Where are we less than or equal to 0? Meaning, where are we below the x-axis and on the x-axis? So looking at your number line, we're looking for below and on. Down arrows mean below, and the x-intercepts mean where we are on. So we have to say that from negative infinity to negative 1, where if we are on the x-axis, negative 1 will now get a bracket. Union, look at your next below, and that's going to be the interval 0 to 3, where both 0 and 3 are included. That's our answer. We are done. Negative infinity and negative 1 included, and then 0 to 3 included. That's where we are. Below and on the x-axis. Okay, perfect. So, did you like that better? Or did you like graphing, knowing end behavior, knowing turning points, doing all that? It seems that algebraically, it was much faster, especially if you have a calculator, right? Okay. Well, the same can be said for rational functions. You can solve the rational functions, the rational inequalities, 1 by graphing, or 2 algebraically. Since we did graphing rational functions on the last section, you know how to do it already, which means we'll just jump straight into solving a rational inequality algebraically using a number line. Okay. Which means this is actually great because we don't have to worry about horizontal asymptotes, vertical asymptotes. We don't have to worry about if we intersect them. We don't have to worry about graphing. We only worry about finding the x-intercepts, the domain, plotting them on a number line, and answering the question. How easy does that sound? Sounds pretty simple to me. Okay. The only thing is you got to put a little bit of fraction work in. So we start off with A, rearrange the inequality and simplify. Meaning, does this inequality look like it can be rearranged? And the answer is yes. We always want 0 on one side, so this means that 3 has to come over. So here's step A. We have 4x plus 5 over x plus 2, subtract the 3, and now you get greater than or equal to 0. Okay, but we're not done because now we need to combine these two terms, which means you need to put 3 as a fraction and multiply by a common denominator. So 4x plus 5 over x plus 2 minus 3 over 1 times the common denominator of x plus 2 over x plus 2. Greater than or equal to 0. Now combine the numerators. I'll get 4x plus 5. I'm going to distribute that 3 already. That negative 3, you have to be careful with that sign. That negative 3. So you're going to get negative 3x minus 6 over x plus 2 greater than or equal to 0. clean it up, and we get our new rational inequality of x, 4x minus 3x is x, and 5 minus 6, you get 1 over x plus 2 greater than or equal to 0. So this is the new inequality we will be working with. Okay, now B, find the domain. So fair enough. B, the domain of this function comes from the denominator. So you take x plus 2, set it equal to 0, and we're going to get x equals negative 2. But we know that can't happen, so we get x cannot equal negative 2. There's the domain. That's B. C, find the x-intercepts. Well, remember from graphing rational functions that x-intercepts come from the numerator. So for my x-intercept, when you set the rational function equal to 0, we take the numerator, set it equal to 0, and solve for x. So x equals 1. Okay, we've done domain, well, we've rearranged, we've done domain, we've done intercepts. Now we move on to the number line. Look how great this is. We do not have to worry about finding asymptotes, which is amazing. So D, we come to the number line. There's negative infinity, there's infinity. We're going to plot the x values we have found. We have negative 2, which will be an open circle. And then we have 1, which will be a closed circle. Okay. Intervals. You have negative infinity to negative 2, negative 2 to 1, and then 1 to infinity. All right. And now we pick test numbers. Zoom in. And test numbers from negative infinity to negative 2, we'll pick negative 3. From negative 2 to 1, easy, we'll pick 0. And then from 1 to infinity, we'll pick 2. I'll fit it on the page later. R of negative 3, R of 0, and R of 2. And let's just go back to our handy dandy calculator and type in the function there. I'll just do classic input, x minus 1 over x plus 2. Don't forget your parentheses. Enter, second graph, delete, 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 delete. And let's see. We've got negative 3, 0, and 2. And once again, we do not care about the number because we're not graphing. We only care about the sign. So at negative 3, we get a positive output. At 0, we get a negative output. And at 2, we get a positive output. Calculator work is done. And then, like I said, I'll just make this fit on the page. There we go. And now based on our signs, we can finish our sign chart, our number line. From negative infinity to -2, we get any positive output, which means we will be above. From -2 to 1, we get a negative output, which means we will be below. And then from 1 to infinity, any number will give us a positive output, so we are above. And now, we use all of this information to answer the final question. Where is this function above the x-axis and on the x-axis? So looking at your sign chart below, we are above from negative infinity to -2. And then looking again from 1 to infinity, but this time 1 is included because we are also above and on at that point. And there it is. That's all we're looking for. So much fun, right? So much easier to solve them algebraically when you're dealing with the inequality. It's better than graphing, I'll tell you that. But that's it. Make your number lines, find all your x values, find your domain, you're good to go. You do not have to worry about the graphs of these if you can solve it algebraically much quicker this way. Okay, that is it. Study for your test. Woohoo! See you at the next lessons.